Okay, this is 7.3 homework help. The first problem gives us this augmented matrix right here, and it wants us to do some operations. So let's do the first one. The first one wants us to do the second row minus 4 times row 1. So I'm going to make this plus a minus. I'm going to focus on this part first. So let me write that down. I'm going to do negative 4 times row 1, and I'll just write that right here. So negative 4 times row 1 gives me a negative 4, and then a positive 12, and then a negative 4, and then a 24. Now I'm going to add that with row 2, so now imagine adding this with this row. And when you do that, you get 0, and we're going to put that in row 2. So you get 0, 12, and negative 11 make 1. And then negative 4 plus 3 make negative 1. And 24 plus negative 6 is positive 18. So the next one then tells us to take row 3 plus 2 times row 1. So I'm going to write 2 times row 1 right here. And that gives me 2, negative 6, 2, negative 12. Now I'm going to add that with row 3, which is the last one. And that gives me 0, negative 4, 8, and 1 plus negative 12 is negative 11. And then the last one wants me to take row 3 and add it with 4 times row 2. So I'm going to do 4 times row 2 real quick. That gives me 8, negative 44, 12, negative 24. Now I'm going to add that with row 3. So 8 plus negative 2. And I'm going to put that in row 3. And this last one wants you to put that in row 3 as well, but we've already put something in row 3, so that must be a typo. I don't know if that's supposed to say row 1 or what, but there's an issue with this problem there, so we're not going to be able to finish it, unfortunately. Okay, the next problem wants us to go from this matrix to reduce it to this one, and it's asking to identify the row operations that get us there. Well, I can see that we're going to take row 2, we're going to multiply row 2 by negative 3, and we're going to add it to row 1, and we're going to put that in row 1. So that's what we need to write there. I think we use this here, and then we put R1 here. It might be hard for you to see at first, but if you start writing it out, negative 3 times row 2 gives you negative 3, 15, 0, 15. And so when you add that with row 1, now this top row, you get 1, 15 plus 2 is 13, 0 plus 3 is 3, 15 plus 4 is 11, which is exactly what we're supposed to get in the new row 1. So that does work right there. That's our operations. We want to take negative 3, multiply it by row 2, and add it to row 1, and put that where row 1 was. Okay, the next problem wants to do the same thing. Identify a single row operation that gets from the matrix on the left to the matrix on the right. You'll notice that these rows are just switched over here. So all we need to do is take row 1 and switch it with row 3, and that's the double arrow. That's what that means. Switch row 1 and row 3. Okay, the next problem you can do in your calculator, if you just type this into matrix A and do row reduced echelon form. I'm going to do this by hand because it's probably easy enough to do a small one like this by hand, but I'm not sure if I'll make you guys do this by hand. I'll probably have you just do it in the calculator. But what we do is, for example, I'm going to multiply row 2 by 4, for example, add it to row 1 and put that in row 2, because that I want to get a 0 here, right? And I want to get a 1 here and a 1 here in order to put it in row reduced echelon form. So I'm going to start with getting that 0 right there. So this is how I would do that. Multiply row 2 by 4 and add it to row 1 and put it in row 2. So if I do that, row 2 times 4 would be, this would be negative 4. When I add it, I get a 0. So I'd get this new matrix right here. This would be a 0. And then so the next one would be negative 4 plus 1, which is negative 3. And then the next one would be 4 times negative 2, which is negative 8, plus 2 is negative 6. So I get this matrix here. And now I can just take row 1 and divide it by 4. And I can also take row 2 and put that in row 1. And I can take row 2 and divide it by negative 3 and put that in row 2. So if you divide this by 4, you get 1, 1/4, 1/2. Divide this thing through by negative 3, you get 0, 1, 2. And there's my answer. So the next one then I won't do by hand because that one's bigger and would take longer. So let's just go ahead and enter that in one end to your matrix and then do row reduced echelon form. So second matrix, we're going to edit matrix A. It's a 3 by 4. And enter in these numbers. Once you get the numbers in, then quit out of there and do second matrix math. Scroll down to row reduced echelon form of matrix A. Go back to second matrix and select matrix A. And this gives you this. That's my answer. Okay, the next question asks if this matrix A is in echelon form and then row reduced echelon form. It is in both. Echelon form is when you have ones on the diagonal, but you don't have zeros everywhere else. So like this would be a 0, but like behind this could be, you know, here's an example of here's an example of echelon form. Row reduced echelon form is when you have zeros everywhere else. So this would have to be a 0. You know, this would have to be a 0. This would have to be a 0. That's the difference. But this one does have zeros everywhere except for ones in the diagonal and numbers in the last spot. This last row means that there's an identity, which means there's an infinite number of solutions to this system if it represents a system of equations, for example. But that doesn't matter. It's in row reduced echelon form. So looking at this one's in. All right, the next problem is problem 7 right here. And it says, given this matrix, is this in row echelon form? It is because the ones here, and it does have numbers elsewhere. But mine has many solutions, infinitely many, because of the fact that this last equation right here is an identity, 0 equals 0, which is always true. Therefore, that means, for me, infinite number of solutions. Now, if you have like 0 equals 1, that means no solutions in this last one. And then obviously, if you have all ones on the diagonal, which would be impossible for this one. So this one, I think it's going to be either one of these two, either many or no solutions. Okay, the next problem asks if this is in echelon form. Would be yes for me and yes again, because it's got the ones on a diagonal and it's got zeros elsewhere. And once again, this last equation means 0 equals 0, means it has an infinite number of solutions, but it is in row reduced echelon form. This next one is not in echelon form. It would have to have a 1 here. And this equation throws it off too. It would have to have a 1 there as well. So this is not. And the last problem, once again, wants it in a reduced row echelon form. So just enter this into your calculator and do RREF of matrix A if that's where you stored this matrix, and it'll give you the answer. All right, I hope this helps.